Good morning, calculus students. Today we'd like to talk about some of the problem. Some student kind of easily to mess up on the calculus final. And one of the packet that I sent out recently, the final study packet, so it generates all the material you guys already learned. And I just want to go over a certain problem, student having trouble to deal with. Okay, so let's start it off with number 10 on the final study packet. So number 10. Okay, let's take a look at this right here. So number 10 is about finding the limit, one-sided limit. So according to the problem, it's listed like this. So limit, okay, again, number 10 on the final study packet. So x approaches 0 from the right-hand side, so it's positive. And then it's 5x to the power of 2x. So now, for those you try to plug in 0 for this one, you'll end up with 0 to the power of 0. So anytime that I deal with 0 to the power of 0, so this one is called the indeterminate form. So for those indeterminate form, we do have 0 to the power of 0, infinity minus infinity. And let's see what else. Infinity over infinity. And 1 to the power of infinity. And also 0 to the power of infinity. Anytime they see those type of form listed like this, so that means it's considered the indeterminate form. So indeterminate form, so the way to deal with this, we need to apply the L'Hopital's rule. So before we apply the L'Hopital's rule, one thing that you want to do with the constant variable base to the power with the variable, so it's better for you to set up the equation as y equals 5x to the power of 2x. And now from here, you want to take the natural log on both sides. So we need to apply the technique that you learned from algebra 2 or pre-cal. So 2x, bring down the power, natural log of 5x. And now from here, this one is given as 0 times natural log of 0 from the positive hand side. So one thing that we notice, so this one is considered 0. So over here, natural log of 5 times 0 approaching from the right-hand side. So we do have natural log of 5x. So the function looks like this. So as you can see that x approaches from the right-hand side, so natural log of 5x. So this one is getting close to negative infinity. So 0 times negative infinity, which is considered 0. So what we got here is natural log of y equals 0. And then we take the base e on both sides. So that means y equals 1. So the conclusion for the limit, so limit as x approaches 0 from the right-hand side, so 5x to the power of 2x. So eventually it's going to be 1. So this one is number 10. And here's another problem that some students having trouble to deal with. And also it's very easy for them to mess up on the final. So the next one will be number 22 on the final study packet. So I'm going to use the next page. So number 22. So that one is about the Rowe's theorem. So one thing before I do the Rowe's theorem, let's go over the definition of the Rowe's theorem. And according to the another packet that I sent out recently regarding all the definitions, formula, things that you learned in calculus. So this one, it also includes the Rowe's theorem, the mean value. So the difference of the Rowe's theorem, you want to test all the conditions first. So the function got to be continuous. So the first condition is showing that f of x must be continuous. Okay, so let me just change that one. So the first requirement, so f of x is continuous on the open interval from a to b. And then number 2, f of x is differentiable. Differentiable, that means you can find the derivative on the closed interval a to b. And then for c, f of a is the same as f of b. So this one, they're just considered the requirements. Number 3, let's see. So make sure that you need to satisfy the first three conditions. And then once we satisfy the three conditions, so we can just set up the outcome. So the outcome is that f prime of c equals 0. And so we can find the value of c. So for number 22, so here's what we got. So y equals negative x to the power of 3 plus 3x squared plus x minus 1 on the closed interval, negative 1 and 3. So one thing that we want to find out, so this one, it is the continuous functions, obviously, because that's a cubic 1, 2, 3, 4 quadnomial. So it's a cubic quadnomial. It's always continuous. So that means there's no gap, there's no hole, there's no vertical asymptotes on the graph. And also, well, so first thing that I want to do, f of x, it's continuous because that it's a polynomial. And then number 2, f prime of x, so it's differentiable. So once we differentiate it, so we got negative 3x squared plus 6x plus 1. And then for condition number 3, you want to find out f of a, so f of negative 1. Would that be the exact same thing as f of 3? So you just plug in negative 1, so we got negative 1 quantity to the power of 3, so it's negative 1 again, negative, negative, positive. So 3 times negative 1 quantity squared, so we got 3. And then plus negative 1 minus 1. So 1 plus 3, then that's 4. 4 minus 1, then that'll be 2. Okay, so that's f of a. And now what about for f of 3? So this one is for f of b. So do it mentally. So we do have 3 to the power of 3, so which is 27, so negative 27. Plus 3 times 3 quantity squared, so it's 27. And then 3 minus 1. Again, so it's going to be 2. So basically the function is satisfy the Rolle's theorem, all the three requirements. So f of x is continuous, f of x is differentiable, and then f of a equals f of b. So now what we can do here, we can just solve for c. So the way to solve for c, we just want to set the derivative equal to 0. So once we set the derivative equal to 0, so we just solve for x. And the value of x, then that'll be the value of c. So for this one here, so we want to set that negative 3x squared plus 6x plus 1 equals 0. So it looks like this one, it's not factorable. If that's not factorable, so what we can do, we can use the quadratic formula. So for this one, you try to solve for x. So we're using the quadratic formula, negative b plus minus square root of b squared minus 4ac over 2a. So solve for x here, so we do have negative 6 plus minus 6 squared, so 36, minus 4 times a times c, so 4 times negative 3, 12. And then times c, so positive 12. And then it's all over 2a, so 2 times negative 3, which is negative 6. And try to simplify this whole thing, so we do have negative 6 plus minus, so square root of 36 plus 12, the quantity of 36 and 12, then that'll be 48. Okay, so 48 can be broken into 16 and 3, so we do have 4 root 3 over negative 6. And you try to simplify that a little bit more, so then that'll be negative 1 plus minus 2/3 root 3. So now we do have positive and negative solutions. So the one that we need to put in for this one is right in between the interval from negative 1 to 3. So it looks like they both work, okay? So for the value of c, so this one could be more than one solutions. So according to the instruction, it's saying that find the values of c. So values, it's plural, so that means it could be more than one solution. So here's what we found. So for the value of c. Okay, so again, this one is number 22 on the final study packet. Okay, so now let's see what else that we have. The one that student having trouble to deal with. So the next one I would like to talk about is number 32. Okay, so we'll take a look at that. 32. It's about the volume of three-dimensional solid. So for this problem, you want to find the volume of a solid that results when the region enclosed by the curve is revolved about the given axis. Okay, so let me just write in a problem here. So this one is number 32. So what we got here is x equals y squared minus 2. And then x equals negative 2. So y equals 1. And then the revolution axis, which is x equals negative 2. So the first thing that you want to do, you probably want to sketch the graph first. Because by the time that you sketch the graph, you'll find out which method you're going to be using. Whether that's a disk method, washer method, or the cylindrical shell method. Okay, remember that the previous video that I put up there on the YouTube channel. So the disk method, so that means the indicator, dx or dy, it's always considered perpendicular to the revolution axis. If that's a cylindrical shell method, so that means the indicator, it's always considered parallel to the revolution axis. Okay, so now let's sketch the graph. So x equals y squared minus 2. So by using transformations, y squared minus 2, so we can just put it in as x plus 2 equals y squared. So it's a sideways parabola, which is facing to the right-hand side. So x minus negative 2. So it's going to be like this. So you want to shift the graph 2 units to the left, because this one is written as x minus negative 2. The whole quantity, so that equals y squared. Okay, so let's put it this way. Another thing that we know is that x equals negative 2, so x equals negative 2, so that means the line right here. And then it's bounded by y equals 1. So y equals 1. Okay, so like this. So it's bounded by the curve, bounded by the line, and then bounded by this horizontal straight line here. So that means the shaded area would be right here. So it's a small region here. And then the revolution axis, so that's considered x equals negative 2. So x equals negative 2, so that means it's revolving around this boundary line. So let's just interpret the graph here. So it looks like there's no space right between the revolution axis and the shaded area. So that means we don't need to do any addition or subtractions. Okay, so remember that for the cylindrical shell method, the way to find the radius, if there's like a big gap right in between, so we need to use the the subtraction and the addition technique. But according to this problem, there's no need to do it that way. So, and also this problem can be solved by either using the disk method or the cylindrical shell method. So let's start it off with the disk method. So the disk method is basically showing that it's pi times the integral from c to d, and then f of y dy. Another thing that you want to find out, so the dx or dy, the indicator, make sure that the indicator, it's always perpendicular to the revolution axis. So the indicator would be this one right here, because that the revolution axis is x equals negative 2. So that means we're using dy for this case. And also the boundary, the lower bound, the upper bound, as you can see that here, it's from 0 to 1. Because that, according to the line of intersections, the point of intersections, it's right here. So it's bounded by the line and the curve. So integral, so pi times the integral from 0 to 1. So f of y, then that'll be y squared minus 2. And then times dy. And then from here, so we just want to integrate it. And then another technique that you can apply for this, it's by using the cylindrical shell method. So for the shell method, the approach would be considered 2 pi times the integral from a to b f of x and then dx. Well, actually, it's not just f of x. It's r of x. Okay, so that one would be r of x times h of x dx. So try to use that the cylindrical shell method. So for the radius, so you want to convert this one. You want to solve for y in terms of x, because that the indicator would be considered parallel to the revolution axis. Okay, so instead of using dy, we're using dx for this. Okay, and then you have to do like some kind of subtractions. Okay, so this one it's easier to use the approach of this method. Okay, so try to integrate it by using part 2 of FTC, so you get the volume. Okay, so that's number 32. Okay, so now let's see what else that we have for the next one. So the next one would be number 52. Okay, so number 52, let's see what that is. So number 52. Oh, that one is applying the part 1 of FTC. So for this one, let me just read through the instruction here. For each problem, find f prime of x. Okay, so the one that's given. So it's given with capital F of x. So it's an integral from -1 to 3x. So the integrand, it's negative t to the power of 3 plus 3t squared minus 2, and then times dt. So according to part 1 of FTC, so it's saying that d dx of capital F of x. So this one, that's the same as d over dx, derivative of the integral from a to x, and then f of t dt. So basically what you need to do, you want to just differentiate both sides here. But by the time that you differentiate it, so make sure that you need to replace all the t by the upper bound. Whatever the value, whatever the expression that you have for the upper bound, so you want to substitute those in for that t variable. And then after that, you want to apply the chain rule for that upper bound. Okay, so what we can do, so basically this one, derivative, integral got canceled. So we just want to put in x for t. So instead of using x here, we're using 3x. So we want to substitute in that 3x for t. Okay, so let me just do that. Okay, so just substitute in for t here, and then for another t right here. So what we got, it's negative 3x quantity to the power of 3 plus 3 times 3x quantity square minus 2. And now from here, not only we need to replace the variable t by 3x, but also we need to apply the chain rule. Because that, by the time you take in the derivative, you're taking the derivative of the outer functions and then the inner functions. So the inner function for this would be 3x. So derivative of this, which is what? 3. So multiply everything by 3. And that will give you f prime of x. So this one is for number 52. And now let's see for number 69. So again, I just want to go over the one that a lot of people are having tough time to deal with. And also those are the ones that I'm kind of afraid student easily to mess up on the final. So 69. So 69 is about finding the derivative also, but it's finding the derivative of the inverse function. Okay, so number 69. So for each problem, find inverse prime of x. Okay, so this one, okay, excuse me about the handwriting here. Okay, so this one, it's given with f of x. It's a quadratic function, so 2x squared minus 4. and for x is greater than or equal to 0. And now you want to find out the derivative of the inverse functions. Okay, so you want to do inverse and then the derivative. So first thing that you can do, you can find the inverse function first. Well, there's a formula for that, but what happens if I don't recognize the formula for this? So the way to find the inverse functions, so back to algebra 2, so we want to rewrite it in terms of x and y, and then we switch the variable. So we got x equals 2y squared minus 4, and then solve for y in terms of x. So f for both sides, divided by 2. And then what we got here is y squared, and then take the square root, both sides. And as you can see, that x is greater than or equal to 0, so that means this one's guaranteed is always what? Positive. It cannot be negative with the radicand. If the radicand is negative, that means we're going to deal with the imaginary number, and which doesn't make sense. So it's always being forced to be positive. So this one is just considered x plus 4 over 2, and then the whole quantity to the power of 1/2. So that will give you the inverse of f of x. And now from here, we just want to differentiate it. So since we do have inverse of f of x, and then by using the power rule, so we just take the derivative. So that would be considered 1/2 times x plus 4 over 2, the whole quantity, to the power of negative 1/2. But don't forget, as you can see the inner function here, so the inner function is showing that it's considered linear. So we still need to take the derivative of the linear functions. So derivative of this linear function would be considered 1/2. Because that is written as 1/2 x plus 2 for the linear function. So 1/2 times 1/2, which will give you 1/4 times the quantity of x plus 4 over 2 to the power of negative 1/2. Okay, so then that would be the derivative of the inverse functions. Okay, so the way to express this, so inverse prime of x. Okay, so now let's see what else that we got for the rest of this. So this one is number 69. So we do have 2 more problems that I would like to talk about here. So 83. Okay, let's see what that is. 83. So 83, you want to evaluate the indefinite integral. So for those who've been watching the YouTube video, the one that I put up for the integral, so there's so many kind of techniques. So the one that we use quite often, it's called the substitution technique. Okay, so especially when the integrand is getting very complicated, so you try to apply the integration technique by using substitutions, and also you want to compare that to the structure, the formula that we already know. So in order to be really solid doing the evaluation with the integral, so one thing that you need to do, you need to study all those formula, and you really have to have a clear picture about the integrand for the structures, okay? So because the structure sometimes it tells you what kind of formula that you need to apply for this. Okay, so now let's take a look at the problem like this. So let's try to use the U-Substitution technique for this. So as you can see that there's a radical involved, so most likely this one is going to be related with the inverse of any kind of trig functions. But how do we set up u and du for this? Okay, so as you do see that here, the radicand, so we do have 9x to the power of 8. And then outside, we do have 3x to the power of 4. Okay, so that means there's some kind of relationship between those two things, okay? And then for those you might be wondering, how come I don't simplify the top and the bottom? Because this one, it really tells you about the structure of the problem here, okay? So now, let's start it with the U-Substitution technique. So what happens if I try to rewrite this one as 12x to the power of 3? Outside the radical, I just keep the same thing, 3x to the power of 4. But what about the radicand? So instead of putting 9x to the power of a again, so can we just rewrite this as 3x to the power of 4, and then quantity square minus 3 squared. So this one, it just tells you one of those formula for the integral. It's considered like dx, and then 1 over square root of x squared minus a squared. So this one basically tells you it's considered inverse of sine of x over a plus constant c, according to that formula. So now we'll take a look at that more deeply. Okay, so this one is number 83. Well, actually, according to that formula, it's supposed to be, it's not inverse of sine, it's actually considered secant. Sorry about that, the formula that we have here. So this one's supposed to be written as secant. Okay, so now let's take a look at that, the structure right here. So what I would like to do for u, I would like to set u equals 3x to the power 4. Okay, because that outside, you also have the absolute value of u for this. Okay, because this one is a structure of, let's put it this way. It's 1 over absolute value of x, square root of x squared minus a squared. So once you integrate it, it's supposed to be inverse of secant. So sorry about that, forgot about the x outside here. So for u, we do have 3x to the power 4. So that means du would be considered 12x to the power of 3. So as you can compare that, the top and the bottom. So this one, 12x to the power of 3. So that's already giving you part of the du. Dx is also given here. So basically the top part, we can just replace the whole thing by du. And then for the denominator, so this one can be written as u, and then square root of u squared minus a squared. And for those you might be wondering what a is, well, a is just 3. It's a constant. So by using that pattern, so this one is just considered the special formula that we have already. So it's an inverse of secant of x over a. So instead of using x here, we're using u. So u over a, so plus constant c. And then afterward, we just want to replace everything back here. So it's the inverse of secant of, well, u, which is 3x to the power of 4, over 3. And then plus constant c. So for those you might be wondering, according to the solution, how come there's an absolute value here? Well, in order to find the inverse of secant, so inverse of secant, remember the restriction for inverse of secant. It's always considered from 0 to pi, okay, the restricted range. So that's why this one we need to put in the restriction. But the thing is that x to the power of 4, that already guarantees positive, so there's no need to put in the absolute value. Unless you're dealing with like a cubic power, odd number power, and then we put in the absolute value. So basically this one is fine. Or you can put in the absolute value, it's up to you. Okay, so this one is inverse of secant of 3x to the power of 4 over 3 plus constant c. Another thing is that, oh, you know what? Something that's missing here. Oh, one more thing that we need to put in for this one. So according to the formula, it's not just 1 over, it's not just inverse of secant. One thing I forgot, it's a constant, it's 1 over a. So outside the quantity here, so we need to put in that 1 over 3. Okay, so one thing that I need to put in there, the extra element, so the coefficient. Okay, so that's 83. And now the last one, number 96. Okay, so to look at that, number 96. Okay, let's see what that is, number 96. Oh, finding the limit again. So number 96, what we got here, it's limit as x approaches 3 from the left-hand side of the step functions, or the greatest integer functions, x plus 2. So one thing that you guys need to be aware of, that the bracket like this, so that means it's called the greatest integer functions. If you try to sketch the graph for this one, so this one is like a staircase functions. So instead of starting here at 0, so we started at -2. It shifted 2 units to the left. 2 units to the left, so that means we're starting here, and then it's an open circle, and then up on the top, and then you want to start it with another solid point, and then it's just a continuation with the staircase. Okay, so this one is showing that x approaches 3 from the left-hand sides. So here's 0, here's 1, and then 2, which is up here, and then 3, the next positions. Well, I'll just count it carefully. So this one, so the y value will be 0. Here's 1, here's 2, and then here's 3. And then the next one would be considered 4. So this one is showing that it's approaching from the left-hand side. Okay, the next one here is 5. So check it out, that at 3, so 3, it's over here. But now if that's approaching from the left-hand side, so that means it's coming from this way. If that's coming from this way, so that means the y value would be 4. So basically just plug in a number, so 4 plus 2. So what's the greatest integer for this? Which is what? 6. Now, but the thing is that if this one is showing that if x approaches 3 from the right-hand side, then that means we're using 5 for the y value. Okay? So you got to be extremely careful which value that you're using for this. So 3 from the left-hand side, we're not using 3 for this, okay? Because this one is a staircase functions. So eventually, so we're using 4, the y value, and then add 2 together. Well, let's see. Okay, so it's 3 from the left plus 2. So this one is number 96. Wait, hold on a second. Did I write down the problem incorrectly? Let me double check this. 96. Oh, to -3. Excuse me. Sorry about that. X approaches -3 from the left-hand side. -3, so here's -2. So -3, then that'll be down here. So try to continue with this. Okay, sorry about that. Let me just restart it with this one here. It's not 3 from the left. It's -3 from the left. So -3 from the left, so that means it's coming from this side right here. So here's -2. Again, just a continuation with the staircase functions. So the next one will be -3 from the left. Then this position would be considered negative. So here's -1. And then you try to continue with the rest of this. So the next position here, then that would be considered negative 2. And also don't forget about this. This one is considered addition. Okay, so let's see. So we got negative 3 all the way down the bottom. Then that'll be negative 1. And for those you might be saying that, are we allowed to use the property of limit? This one we try to apply the properties of limit, but unfortunately this one is considered one whole quantity, so we cannot separate them. So let's just do the interpretation. So negative 3 from the left. So here's the one approaching from the right hand side. That'll be negative 1. And then the limit, the one approaching from the left. Then that'll be considered, well, the limit here. Then that'll be considered negative 2. But what about if we just plug in a number x first, okay? The value of x. Then that'll be negative 3 plus 2. So negative 3 plus 2. So this one will be showing that it's negative 1. So the limit x approaches negative 1. Then that'll be 0, which doesn't make sense. Okay, let's see. So according to the final solutions, the final limit would be considered negative 2. So the y value would be negative 2, which is down the bottom here. Okay, so let's think about this way. So negative 3 from the left. So negative 3 from the left, that means we're using negative 3.0001 plus 2. So then this one will be the number, well, the value for this one will be considered negative 1.001. So that means we're actually taking the limit as x approaches negative 1.0001. Okay, so negative 1.001. So anything that's considered negative 1.0001, so that means we don't use any, well, we don't use any decimal for this. Anything that's less than negative 1.001, so that means we're using this number, which is negative 2. Because this one is called the greatest integer functions, so there's no decimal involved. So again, let's do the interpretation. So negative 3 from the left, so that means the number we're using is negative 3.001 plus 2. So that would be negative 1.001. But according to the graph, so anything that's considered negative 1.001, we'll just round it to negative 2. So that means the final limit is going to be negative 2, according to the staircase functions. Okay, so that's it. So that's the video for all the critical problems a lot of people having trouble to deal with. Number 10, 22, 32, 52, 69, 83, and 96. Okay, so prepare for the final. And then I'll see you guys next time. Take care.